All right, so today we're going to simplify radicals. So it's like what we've done in the past with simplifying your square roots. The only new thing is that if we simplify an even root and the variable comes out with an odd exponent, you have to use absolute values for this reason right here. If I have the square root of x squared and you try to tell me the answer is x, what happens is that if x was originally 5, that's fine. 5 squared is 25, square root of 25 is 5. What happens if the original answer was negative 5? Negative 5 squared would be 25. The square root of 25 is actually positive 5. So that's why we put absolute value symbols around it. So square root of 16x to the 8th would be 4x to the 4th. When we have roots here, the quickest way to do this is just divide each of those numbers. So you're dividing 8 by 4 and the 12 by 4, because really the way this would be rewritten is you'd have a 1/4 power, and then a power to a power you'd multiply. So it would look like 8 to the 12, and then like that, and then you reduce them. So that's why I just do a shortcut of dividing each of them by 4. So it becomes a square, and then that's a y cubed. Even root, odd exponent. So cube root of 7 does not come out, so that stays in, and then 3 goes into 6 2 times. So for this one right here, we're going to break it into 2 square roots, one that's going to be a perfect square root and one that won't. So 9 breaks down into 9 and 2, where 9 is a perfect square root and 2 is not. So I'm going to rewrite this as 9x squared y to the 4th times square root of 2x. So all I did was out of the 3 x's, I put 2 of them here and 1 of them here because now it's going to go in evenly. So this whole square root is 3x y squared. This one would be a decimal, so you're going to leave it inside. Technically, that x should have an absolute value around it. I'm not going to use absolute values anymore, but just remember, or not say it, I'll just put them on there. But most of the time what we'll do is delta math and stuff will say all variables are positive, or they'll say like x is greater than 0. So if x is greater than 0, you don't have to put the absolute values. And that's the assignment I assigned you. So this right here, cube root. 8 is a perfect cube root. R cubed would be, out of those 5, 5 of them would be, and then 2 of them aren't. Into 10, I can say 9 goes in evenly with 1 left. Right? Because it's 9 and 1 make 10. That makes 5. So now cube root this side. You get 2rst cubed, cube root of s squared t. This was a cube root, no absolute values needed. All right, so for this one right here, the 4th root that are perfect 4th roots would be x to the 4th, y to the 8th, z to the 8th. The ones that are not perfect 4th roots is the 10, an extra 8, and 2 z's. So 4th root, this whole side right here, so this is going to be 7x cubed times. Now I'm going to break this down. 180. Right, 9 is not big enough. Oopsie. 180 divided by 36. There we go. So this is going to be 36 times 5. So then the perfect square root would be the 36. The not perfect square root would be the 5 and the x. So you'd get 7x cubed times 6 times x times y square root of 5x. Now you're just going to do 7 times 6 right there. That's how you get your 42. X to the 4th, y. Again, delta math says all variables are positive, so you don't have to do this part. 10 goes into there evenly 8 times with 7 remaining. Oops, why did I do 8? It's x to the 8th. X to the 8th. There we go. Because 10 goes into 80 that time. So first thing I'm going to do is put these together. Now I'm going to split up into 2 of them where it's perfect square root. So let's find the perfect square root that goes into 720. Okay, bigger than 36. So it's going to be 142. Okay, so this is 144, x to the 4th, y to the 4th, and this is a 5 and a y. Square root this side, I get 12. Multiply your outside numbers here. Multiply your inside numbers. 12 So this can break down into 4x squared y squared. And then you still have a 3 back here. Square rooting this gives me 2xy. So that would be 40xy radical 3. Absolute values would go around those on this problem. So first thing I'm going to do here is to divide these to make it one square root. So that gives me 6 x to the 5th over an x makes it x to the 4th. And that would be, I can't reduce that one, so it's y to a negative 3, but it's really on bottom. So that doesn't come out. The x squared will come out. So we have x squared, and then a y will come out on bottom. And I have a square root of 6 over y. You probably, some of your teachers might want you to rationalize this. This is fine for me as an answer. This was really like putting the y cubed on bottom. So that's why I said 2 of them came out on bottom and 1 of them stayed in. So this is a cube root. You're going to do 162 divided by 3. So I have 54, and then subtract my exponents. So 27 should go in that number. Yep. So then I have the cube root of 27y cubed times the cube root of 2. So this gives me 3y. So 200 would be 100 times 2. So I'm going to do square root of 100, x to the 4th. So square rooting this gives me 10x squared. All right. Oops, yeah, I was a little far down on that one. All right, 48 should be 16. Let me see. Yep. See, 16 and 3. So I'm going to break this into 16a squared, b to the 4th, c squared. What was left was that 3 and one of those a's. So square root all these. Technically, the a should have an absolute value around it, and the c would have an absolute value around it. But again, the delta math does not make you do that.